Hello everyone. In this lecture, we are going to continue our discussion of SaaS service delivery model of cloud computing. So talking about SaaS in particular, software as a service, if you go back in the 1990s, you could say that web services were the equivalent of today's SaaS. The way web services were delivered, like I am talking about 1990s and 1995, that period of time when having an encyclopedia present over the internet and a person with access to internet can find any information at one go, that was a very big deal. Looking at information, looking at news from the search engine at that point of time, so that was also delivery of a service, delivery of a computing utility, delivering software as a service. It just had another name. It was web services at that point of time. And if you try to understand it from that perspective, you will be able to better understand what SaaS actually means as a model in today's cloud computing world. So when we talk about SaaS, we are talking about two parties who are involved. The first party is your consumer, your end user. So your end user is there who is waiting to use or work upon or exploit or get engaged in any kind of service. For that service, the user is going to pay. The consumer, the end user is going to pay. On the other side, we have our cloud service provider. Our cloud service provider is the one who is responsible for providing that service, right? So there are two parties, your consumer and your cloud service provider. When we talk about SaaS, we are particularly talking about the services which can be accessed by your small input output devices, maybe your phone, maybe your tablet, even your laptop. It needs a very limited set of instruction, it needs a very limited set of input output. All you need to access a SaaS based service is to have a session with your cloud service provider. So what normally happens is that a consumer is going to contact the cloud service provider via the internet, right? Then they're going to exchange some key by using some standard protocol. Once that key is agreed upon, then a session will be established. Through that session, those two parties are going to talk, right? Once they have established a session, then they are going to authenticate. The consumer is going to say that I am so and so person and this is my password, just register it, connect it to my account and let me use your service. The user, what is the requirement from the user's perspective? The user needs a user interface, your typical digital device, to interact with your cloud service provider. That is the basic requirement along with an internet connection. Once you have a user interface, then you can use the portal in front of you to navigate whatever service is being provided to you. You're going to give some input, you're going to take out some output. All of that interaction is going to happen between two parties. As you can see in this image, we have clients or consumers and we have cloud service provider. So we have our first party and we have our second party. So the consumer is going to connect through the internet and talk to the cloud service provider. They will exchange keys, they will establish a session, and then the consumer is going to say, this is my username and this is my password and so service I want to access. The cloud service provider, what the CSP is going to do, the cloud service provider will take note of the application which you want to use. For example, in this diagram, if you can see, we have application A, application B, application C, and we have a stack of available resources. So we have set 4, set 5 and up to set n. So the consumer is going to come and the consumer is going to say that I want to use so and so service. So here consumer C1 is using the B application and the C application. For every application that the consumer is going to use, for every application, your cloud service provider will correspondingly allocate some resources, be it your processing power, be it your storage, be it your network, any type of computing requirement which is needed, the resource which is needed. If that resource is available, then it will be allocated to your application, and the control of this application will be given to the client, right? But if we are talking about SaaS, not PaaS and IaaS, so here the control is very limited. The user can simply give the input, take the output, exploit the service which is available. The resource is here. How that software, how that application is maintained, all of those controls exist over here. And what truly happens between the consumer and the cloud service provider is an interaction which is dynamic in nature, right? Because you are exploiting it using the internet. You're just using the resources. On top of those resources, you're running the software stack, the application stack, and you are getting what you want out of it, right? So overall, the resources are allocated to the applications which are pre-built, and those applications are offered as services to the consumers. Now on the other side, if we go to this half of the diagram, you can see that another client has entered, another customer has entered. So the customer is C3, and C3 is using the internet and again talking to the cloud service provider, and now C3 user wants to access application A and application B both, right? So here is the beauty. If your application is created once, your software is present over here, you can simply use that application and you can allot a resource, some processing power, some resource can be allocated to the application, and the control can be handed over to the consumer. So it does not matter how many consumers you have, how many clients you have. This one can go from C1 to C2 to C3 up till Cn. And we assume that cloud has a unlimited resource pool. So this is our resource pool, available resources. All the time, whenever a copy or a service is instantiated from this stack of apps, it will be allocated some resource to run on, and that combination will be started. The control to that combination will be provided to your customer, right? So let's read from the PPT. Here in the diagram, in the figure, the cloud is providing services to two clients in the first case. So we have two consumers, two clients, C1 and C2. The cloud provider possesses an inventory of software applications, apps in the figure. So this inventory of software application, this is our service combined with the hardware. Like without hardware, it is of no use for the consumer. So if you combine this software application along with the hardware, it becomes your software which you are going to deliver to your consumer. The cloud provider possesses an inventory of software applications, apps in the figure, that it is offering to clients for use over the network, right? So your consumers are just using it, not owning it, and they are doing so over the network because they do not practically have the direct access. The cloud provider possesses application execution resources labeled as EXR in the figure. So here we have a stack of applications and we have a stack of resources which are available. So client C1 is currently running two applications, B and C. Over here we have client C1 who is running two applications, B, C. So one execution resource number 1, execution resource number 2. And when the second client entered, we allocated execution resource number 3 to this third application, right? Even though the application is same, C, C, the resources are different, right? And once this session terminates, suppose that the client 2 has completed his or her work and has now left the network. Once this client has left the network, then this resource will be freed and added to our stack of available resources. So this management goes on all the time, orchestration we call it. So execution resource number 1 is supplying the processing power and other resources to run the application B. Similarly, execution resource number 2 is supplying the processing power and other resources to run our application C. The execution resource might be any computing resource. It can be a physical computer, it can be a virtual machine, it can be a server program, it can simply be a processor, it can be storage, it can be anything, any type of resource which satisfies the objective of your application. Client C2 is using one application C which is supported by execution resource number 3. Now, if we come over here, right, whatever was written in the PPT, I already explained it. But if you need to understand what is really going on over here, why it is dynamic in nature, how are we interacting, why is it abstract in nature? See, these 3 keywords are important to understand what is going on over here. Abstraction means to separate out, to create modules which are independent in nature. So they can be used for particular objectives. For example, these applications, right? Maybe there is one mailing application over here. See? So let's say that A is the mailing application, not C, because C is overused, C is used here. So let's assume that C is our mailing application. Now, if client 1 is using the mailing application only to mail images, because the person wants access to a image database, so the person is using it for images all the time, and the second client is using it for music, maybe, right, for audio interaction, and over here we have pictorial interaction. So both of them are using the same service, they are using the same application, but the objectives are different, right? And the execution resources, they are different, so they have independence. Both of them can work any way they want to, right? Exploiting the same application, the application remains same. It can be copied 1,000 different times. 1,000,000 users can use this same application C, and all it would need for the cloud service provider to run this application is to have our execution resources available all the time, back to back. Just, making a stack, supporting it by hardware and giving it to the user. Once this user leaves the stack, supposedly this person, just imagine for a moment that C2 does not exist over here, right? So C2 has left and now only C3 is present. So C3 can again go, and maybe this execution resource is allocated to C3. Same hardware, same stack of software, right? But the details will change, the session will change, and that will be stored for every user, for every consumer. It will be stored by our cloud service provider. And by abstraction, we again mean the independence which is there between the resources and between the applications, because you can add any number of applications you want, you can change any application which you want, but any change in A is not affecting any change in C. If I change B or if I replace B, then it is not going to affect my application C. So there is abstraction over here. Second word is our interaction which is happening on the go, right? It cannot be like C1, once C1 entered the network and C1 said that I want to use application B, and execution resource number 1 is allocated. Maybe the session is interrupted. C1 went back home or slept, and after 4 hours C1 has come back and C1 is saying I want to use application B again. So it is not important that resource number 1 will be allocated again to him. Maybe resource number 7 is allocated to him, right? So it is all dynamic in nature, and it all depends on the interaction between our consumer and our cloud service provider. Talking about the observations, same application can be rented out to different customers. So we have the very same application, and the same application is given to different customers. Over here we just looked at a figure with 3 people, with 3 clients at most. But when we talk about cloud services, we're talking about thousands or maybe lakhs of customers who are there at any given point of time. If I am using Gmail, if I am logging in every time, what is going on? The same application, then my personal data is added to that application, whatever my personal requirement is, and then it is instantiated on some hardware and the control is provided to me. How many customers are there all over the world, right? So that is one very key trait of software as a service, that same service can be used over and over again, complemented by the personal data of the consumer. Second, additional client requests application from the cloud provider allocates extra execution resources. So these resources are also very, very independent in nature. Whenever an application needs more resources, it will be allocated more resources. And when the session terminates, the resources will go back to the resource pool. We use this term very often, resource pool. So what we mean by resource pool is simply a collection of all the resources which are present under a cloud service provider. It can be present in any place all across the world in any form, virtual or physical. So we call it as a resource pool, collection of resources. Maybe you have 1,000 processors or 1 lakh hard drives, right? If that resource is used, then it is mapped to some application. If that resource is not used, then it is added back to our resource pool. So that is all about this topic. Next, we are going to talk about the scope of control under SaaS. Thank you very much.